Welcome to Engineers Academy. Subscribe to my channel and click on the bell icon to receive the notification for the upcoming videos. Now I am going to solve this problem 132. So in this problem it is said that picking up a load from position P, a cable tension T of magnitude 24 kN, right? So there is a tension in this cable, right? And the magnitude of that tension is 24 kN, right? So we are asked to calculate the moment which this T produces about the base O of the construction crane, right? So we are asked to find the moment about this point O due to this tension T in the cable, right? So let's assume that this is the origin, this O is the origin, right? So we will draw our moment arm vector, let's suppose. So this is our O moment arm vector. From this point we can draw this moment arm as well, right? So let's suppose if I have this moment arm, right, from this O to B point, right? So this is our moment arm, and we could have drawn this as a moment arm as well, right? We can take this as a moment arm as well, as I have told you people, right? So it's up to you people that whether you people choose this as a moment arm or this as a moment arm. So for this particular case I will choose this as a moment arm, right? So then we will find the moment about O using the cross product method. So moment about O will be equal to ROB cross T vector, right? So I will write T. So moment about O will be equal to ROB cross T. So first we will determine the coordinates of point A and B. So what are the coordinates of point B, right? So if this is the origin, so we need to travel 6 meters in the along the x axis, right? So I will write 6, and then this total distance is 18 meters along y. So this distance is 5 meters. So then we need to travel this much distance along the y axis, right? So this much distance is 18 minus 5, right? So this much distance is 13 meters. So I will write 13. And since this point B is in the xy plane, so there is no need to travel along z. So this will be 0, right? So these are the coordinates of point B. So now we can write the ROB vector directly, right? So if I write that the moment about O, so ROB vector. So since this is the origin, so we can directly represent that moment arm vector in terms of these coordinates, right? So I will write 6i plus 13g, right? So this is our moment arm. Now first we will find the T vector. So T vector will be equal to T magnitude and the unit vector from A to B. So this will be equal to T magnitude AB vector divided by AB magnitude. So now for that we need to determine the coordinates of this point A, right? So what will be the coordinates of point A? So let's suppose if I write it here. So to reach this A, first we need to travel along the y-axis, right? So how much we will travel? 18 meters along y, right? So I will write that along y we need to travel 18 meters, and then we will reach this point, and then we will travel 30 meters along z, right? So I will write 30. And since this point A is in the YZ plane, so there is no need to travel along x, so this will become 0, right? So these are the coordinates of point A. So now the T vector will be equal to, the magnitude is 24 kilonewton, and AB vector, so what will be that AB vector? So we will subtract the coordinates of A from B, right? So this will become 6 minus 0i plus 13 minus 18j plus 0 minus 30k, and we will divide it by the magnitude. So this will become 6 square, 13 minus 18 5 square, and this will be plus minus 30 whole square. So this will be the magnitude and under the root 2. So if I solve this, so this will be equal to, so when I solve this, so this magnitude comes out to be 31 and this is 24. So 24 divided by 31, and when we multiply this with all this all these components, right? So then this is the t vector in terms of I, j and k, right? So now we know this t vector, so we can take the cross product, right? So this is the t vector which we have found here. So this is the t vector. So we will find the moment by using the determinant method. So moment about O will be equal to, so I will write I, j and k. So this is 6, 13 and 0, 4.64, 3.87, and this will be minus 23.23 k, right? So moment about O will be equal to, so then I will hide this row and this column, so we will take determinant of this. So this will be 13 into this, right? So 13 into minus 23.23, and this will be multiplied with I. And then we will hide this column, so we will take determinant of this. So with j we will write minus, and this will be 6 into this minus 23.23, and this will become 0, right? So I will write j. Then I will hide this column, and then we will write plus, and this will be 6 into 3.87 minus 13 into 4.64, and this will be k, right? So if I solve this, so this will be the moment about O. So when I solve this, so this is the moment about E, but I have done very small mistake, right? So here this is 13 minus 18, so this will be minus 5, right? So here we need to write minus 5 here, right? So this will be minus, and this will be again minus 3.87, and this will be minus 5 whole square, right? So with square, minus and plus doesn't matter, right? So but here it matters, right? So this is minus, this is again minus 3.87, so here we will have minus 3.87, so here we will have minus, right? So when we solve this, so then this is 6 into minus, so this will become negative, and this is also negative, so this will add up, so we will get this minus into 3.54 g. So this is the moment about O due to this tension T in this cable, right? So this is the solution of this problem.